This video is on exponentials and logarithms. We are going to be rewriting and converting each equation into its inverse form. So if it is in an exponential form, we want to convert it into a logarithmic form. If it is in a logarithmic form, we want to convert it to an exponential form. So the helpful hint for rewriting, or to convert, is that the base is always the base, and the exponent will never touch the log. So what I'm going to do on these problems, I need to figure out which form it's in and which form it will go to. So before I do any math, I'm going to go ahead and write out which form it's going to turn into. What is its inverse form? This form, number one, is in exponential right now. So the inverse of that would be a logarithm. So I'm just going to put log beside it because that's what I know it's going to turn into. Number two, it's a logarithm right now. It'll turn into an exponential. 3 is log. It'll turn into an exponential because that's the inverse. 4 does not have log in it, so therefore it also has an exponent. It will be an exponential right now, so it will turn into a log. 5 has log in it, so it will turn into an exponential. 6 does not have the word log in it. It's not a logarithm, so it will turn into one. 7 is a logarithm, so it will turn into an exponential. And 8 does not have log, so it has to turn into a log. Now, so we can plug these into our calculator and actually check them, especially the exponentials. But this one, we can't plug a log base 5 into our calculator. Some calculators can, some cannot, and that will be in a different video. But we can plug in 10 to the third, and if that equals to 1,000, we know that this is correct. So we want to be able to convert these to exponentials so that we can check and see if they're correct. So on all these problems, we already know what they're going to be turned into. With that, I'm going to take my pen and write out part of what it's going to have in our answer. If I'm going to convert this, I know I'm going to have an equal sign in it, and I have to have that log in it. My answer will look something like this, where I have a log and a base, but I don't know what my base is yet, of a value, and it will equal to something. So even up here, I will have a number equals to a log of a base of a number, and then another number here. I will write log. I don't know what my base is yet, so I'm going to leave some space. I don't know what my number will be yet, so I'll go ahead and put an equal sign. Because there's going to be 3 numbers. We're going to use all 3 of these numbers. We're not going to change any of them. We're just going to make them look different. That's it. So I'm going to have my log, leave some space for my base and my number, because that's what it has, a base and a number, equals, and I'll have another number on the side. So when I look at number 2, it's going to become an exponential. So all I know is that it's going to have an equal sign. I know I'm going to have a value on the left with an exponent. So if I look back at this format, I need to know the base, and then I need to write the exponent. It's going to equal to another value. So we're going to be using the 3 numbers that are in this problem. We have a 5, a 25, and a 2. So I can actually go through all of these and rewrite them, at least with this little piece of information. So for this logarithm that's turning into an exponential, I'll just have an equal sign. For the exponential turning into a log, I'll have the word log, leave some space, equals. Turning into an exponential, I'm going to have an equals. Turning into a log, I'm going to have a log, space, equals. Turning into an exponential, I'm going to have an equals. Turning into a log, I'm going to have log, space, equals. So what I'm going to do now is I'm going to take my helpful hint that the base is always the base. So I need to figure out what the base of the problems are. The bases are always it's always on the bottom of something. So if we look at this problem, there are 3 numbers, a 10, a 3, and a 1,000. The 1,000 is by itself. The 3 is an exponent, so it's up top, but the 10 is holding that 3 up. So your 10 is actually your base. The 10 is the base of this problem. So then the base for a logarithm goes a little underneath it. It's almost like a subscript. That's where the 10 goes. So if we look on number 2, the base of this problem, that's called a log base 5. that 5 is your base. That 5 on an exponential is going to hold up the exponent. So I need to put my 5 as a normal 5 on the left-hand side because I know I'm going to have an exponent up in here attached to the 5. So I can go through and do all of these. The 8 is your base on this one. So it's going to turn into an exponential. So I know my 8 is going to be a normal sized 8 on the left-hand side. Number 4, I'm going to write it as a logarithm, so I need the number down here. The base is what's holding up the exponent, so not the 1 over 27. The negative 3 is your exponent. The 3 is your base. So that 3 is going to become almost a little subscript down here. That's a log base 3. It is pronounced log base 3. Number 5, the base is a 2. And we want to write it as an exponential, so it's going to become a normal size 2, and we're going to have an exponent on it. For number 6, our base is the 4 because it's holding up that negative 1. This is a logarithm. It's going to turn into a logarithm, so it's going to be log base 4 because your base was 4. On number 7, the base is a logarithm. The base is the 6. Turns into an exponential, so it's going to be a normal size 6 because we're going to put an exponent. For number 8, the base is 5 because it's holding up the exponent. For a logarithm, your base becomes log base 5. So it's a little 5 underneath the log. So we actually have all of our bases written out. The other helpful hint was about the exponent. There are 2 hints. There are 3 numbers. So if we know where 2 of them go, we can automatically find the third. So the exponent never touches the log. Now this one is a little different. Sometimes you're going to be given the exponent, sometimes you're going to be given the log. So you have to look at, if you're given exponential, the exponent will not touch the log. If you're given a logarithm, you have to find the part that's not touching the log, and that will become your exponent. So for an example, this one is an exponential. So you have the exponent. The exponent is the 3. That 3 cannot touch this logarithm. That means it has to be on the other side of the equals. So there's going to be a normal size 3 on the other side. But on number 2, we want to write it as an exponent. So we need to find the other way. We don't have an exponent right now. So what part is not touching the log? The 2 over here is not even on the same side as the log. So that is going to become our exponent. It will become 5 to the 2nd power. And then we'll keep going. So on number 3, again, I'm just going to find my exponents. So again, this is a log, so the part that exponent will never touch the log. I need to put it into exponential, so go to the part that's not touching the log, which is that 1/3. This is what becomes our exponent. So we put 1/3 as an exponent. On number 4, we want a logarithm. The exponent never touches the log. So our exponent, we have an exponent of -3 that cannot touch the log. So it has to be on the other side of the logarithm. So we'll have -3 on the other side. On number 5, we want it as, we need the exponent. So the part not touching the log is 5. So our 5 is going to turn into our exponent. So 2 to the 5th. On number 6, we want a logarithm. So we have the exponent. The exponent on this one is -1. The -1 cannot touch the logarithm. The exponent never touches the log. On this next one, we need the exponent. So we need to find what's not touching the log is the 0. So the 0 becomes your exponent. And then number 8, we have the exponent of 3. So that cannot touch our log, so it has to be on the other side. Now, we've already used 2 of the 3 numbers. So the space that was empty in each of them is where we put that other number. So on number 1, the 1,000 has to go into this space right here. Number 2, the 25 has to go into this space on the right. And we can see that 5 squared is 25. On number 3, the number that we haven't used is the 2, so it's going to go in that empty space. 8 to the 1/3 can also be written as the cube root of 8. Any exponent that's a fraction can actually be written as a radical. That would be, the denominator is your index, so that would be a cube root of 8 to the first power, because your numerator is the power of the base that's remaining. For number 4, the part that's still remaining is the 1/27, so it's going to go into that space in the middle. For number 5, the part that's still there is 32. Put it on that empty space. 2 to the 5th is 32. For number 6, we're missing that 25/100ths or a quarter, so that will be written in this space. Quarter, 25/100ths. For number 7, what's missing is the 1, so we're going to put the 1 on the empty space. 6 to the 0 power, anything to the 0 power except for 0 is equal to 1, so that is correct. And then the last one, the one that's missing, is the 125, so that's going to go into our space. This is just a way to remember how to convert it. So it becomes 10 to the 3rd equals 1,000, becomes log base 10 of 1,000 is equal to 3. Now this logarithm, because it has a log base 10, can be done in our calculator. Every calculator can do this. So if I turn my calculator on and I look at my buttons, I have a log button right there. This log button has a base of 10 in the calculator. So every calculator that has this button already has that base of 10. So that base of 10 is already here. So if I press that log button, just the log button, I just press the button, I don't have to put that 10 in there because it's already there. That's why I can't put this log base 3, because I can't come over here and change the base right now. There is a way to do this in certain calculators, but I'm not showing that in this video. So this 10 is already here. I don't have to worry about it. This is called a common log. So I can type in that 1,000 into my parentheses. And then I'm going to close my parentheses. And when I press enter, it should give us 3. And it does. What that means is that we did write this correctly in our log form. The reason we do this is because if I had to solve for this, I cannot put log base 5 into my calculator right now. I would need to convert it so then I can solve. I know what 5 squared is. I know it's 25, so I would be able to figure that out. So rewriting is an essential step of being able to solve exponential and logarithmic functions. We want to be able to solve things, so we need to convert it into a format that we can use in our calculator.